So today we are on now lesson 4. We're talking about points, lines, and angles. Um, so when we talk about a line, when we're talking about geometry, a line is, of course, like something that goes on and on forever in both directions. That's why we generally put arrows at the end of it. It's comprised as an infinite number of points in a row. But even more importantly than that, a line is actually an angle, and it's called a straight angle. It's a straight angle because there's no bend to it whatsoever. A line, also called a straight angle, has an angle measurement of 180 degrees. Now what this means is that when we are given angles that are put together, we can see if they lie on a line. So these three angles, if we look at them, they all lie on the same line, which means when we put all three of them together, the teal, the red, and the green, they add up to 180 degrees, since they all lie on a straight line. So what I can do here then is set up an equation. 87 plus A plus 32 is going to give me 180 degrees. And now I can solve for A. I'm going to combine like terms on this side first. 187 plus 32 is 119. So A plus 119 equals 180. I subtract 119 from both sides to get A is equal to 61 degrees. It's a similar problem here. The one trick here is we have this unlabeled angle. However, I know that this box means that this angle is 90 degrees. All three of these angles, again, lie on the same straight line, so I can set up an equation. 90 plus 60 plus, this whole angle is called C minus 30, equals 180 degrees. I'm going to combine my like terms again. So 90 plus 60 is 150, minus 30 is 120. 120 plus C equals 180. I subtract 120 from both sides. Now I get C is equal to 60. There's another type of angle that becomes really important in this unit, and these are called vertical angles. Vertical angles are what I like to think of as bow tie angles. So this is an example of vertical angles. Vertical angles are made up of two lines that intersect. Whenever we have vertical angles, we know that the angles across from each other, these bow tie angles, are congruent. So what that means here is angle ABE, ABE is congruent to angle CBD. A few things here. First things first is this symbol. It's like an equal sign with a squiggle on top. That means congruent, or the exact same size. Angle ABE is congruent to angle CBD. We always label angles in order. So notice how when I traced this angle ABE and angle CBD, notice how I never had to take my pen off of the page. I didn't do CDB. That doesn't make any sense, right? They have to be able to trace in order. And what that means is that the vertex means like the point, the bend, is always the middle letter. In this vertical angle pair, so we have one bow tie pair right here, this ABE and CBD. We actually have another pair involved here as well. So this is a situation where you might want to have different colors out. Geometry is really, it's hard to see things sometimes, so I find that the more that I color code, the more I really get out of my answers here. So I know that there's this bow tie pair. Do you guys kind of see the bow tie there? There's also going to be this bow tie pair. The orange bow ties, those angles are across from each other and they are also going to be congruent. Sun just went down a little bit. So that means angle A, notice how I'm tracing in order, B, C, here's that funny symbol again, is going to be congruent to angle E, B, D. To mark congruent angles, you guys might have noticed how I drew in little curves. That's actually a really specific math thing. So when we want to show that angles are congruent, that's how we do it. So congruent angles are going to be marked with like little curves like this. Sometimes on a picture, you might have more than one set of congruent angles, how ABE and CBD were congruent. So I marked them with one little curve. Angle ABC and angle EBD are congruent, so I mark them with two curves. Like that. You might also see it in a way where it's a curve with a little dash through it. That's another way that we show congruence. Don't worry if that feels confusing to you. This is something you're going to get exposed to over and over and over again throughout this unit. Let's look at the second example. We have these two intersecting lines. So I can already start to think about my bow ties and where do I see bow tie angles? I know that these two I'll mark off in green are going to be congruent. I know that these two I'll mark off in orange are going to be congruent. And I'm doing that before I'm even reading the problem because I already know that information. Now I'm going to read the question. This says M angle QWB. The M, when you see an M, that means the measure. So this is really saying the measure of angle QWV, pause, trace. Where is QWV? QWV, measure of angle QWV is 140 degrees. I need to find all other angles. Well, I've already marked that this angle is 140 and my bow tie angle, the one across from it, then will also be 140 degrees. Now I can take it all together though. Check this out. If I cover up the bottom half of the image and I just see these two angles, what do you notice about these? These are on a straight line. And we already know that straight lines are called straight angles. So they add up to 180. So 140 plus what gives me 180? 180, well, 180 minus 140. That means this angle measure is going to be 40 degrees. Now thinking about my bow tie angle, I know that this one is also going to be 40 degrees because they are congruent. So now I know the measure of angle QWX is 40 degrees. I know the measure of angle XWY is 140 degrees, and the measure of YWV is 40 degrees. So now I know vertical angles, my bow tie angles, are always congruent. I also know that a line has a measurement of 180 degrees. And knowing these two bits of information gives me a ton when I am solving problems.